Hello chemistry, welcome to 9.1. I hope you appreciate this video because I risked life and limb and my safety and the safety of members of my family to travel through the great drizzle of 22 and get here. Can't believe I'm doing this. The world is shut down, but I'm here. So I hope you appreciate our family sacrifices to risk our life in this incredible weather we're experiencing this morning. By now you should have had the 9.1 quiz taken. You should have had a PDF, fill it out, and now we're ready to grade that quiz and explain what this is doing. So if you didn't do that, pause the video and come back with us. But answers for these: 1, we're going chemical reaction. 2 and 3, you're taking your choice between gas getting produced, heat getting produced, or heat getting absorbed. Color changing, or the appearance of an insoluble substance. Any of that stuff would be a win. 4 is a chemical equation. 5, there were 2 rules. 1 rule is you must know how the substances react and what new substances they form. That's a long rule, so if you only got half of that, that'd be a half point sort of moment. And then the other rule is that the equations have to be balanced. 6 is that mass is not created or destroyed. We've had that before, if that sounds sort of familiar. So that's our points from today. There's no math to do, there's no homework to do. There's number 1, A and B, that you could start to do that'll fill in to be part of a larger homework someday, but that's not really super urgent. What we're doing for tomorrow is 9.2. I strongly suspect the 9.2 is going to end up on a video as well, because tomorrow is when the actual real winter weather comes. I don't know what we're doing today. If this is the new standard of what weather closes schools when it drizzles and is in the 40s, I'm not sure how we'll ever have school again. But 9.2, we'll take it as it comes. But 9.1 feeding into 9.2, let's see, looks like 12 new points will come out of reading 9.2, so that's going to be a Meteor section there. So 12 points from 9.2. Changes from today: 1 will go backward. What is a chemical reaction? So you'd say an interaction among chemicals that brings about change. Not appearing on the quiz, but just a reminder, chemical change we had way back at the beginning of the year. We talked about chemical changes. Chemical change was any change that changed the composition of something, meaning a new substance was formed. And we did a whole chapter where we were like, baking a cake was a chemical change because a gas was produced, you could smell it. But cutting a cake was a physical change. It didn't change the nature of the cake. The cake was very different before you baked it than after. You formed a new thing. But when you cut the cake, it's just cake. You didn't make it the same type of change to form a new thing. 4-point question: instead of 2 and 3 being 2 of the 4, we'll ask for all 4 signs that a chemical change has taken place. So gas produced, I just alluded to a second ago. You can smell it sometimes when a new thing is being formed, whether that's through smoke or some sort of aroma being set off. Heat produced or heat absorbed, those 2 ideas together make a full point. So sometimes things produce heat, sometimes they absorb heat. If you're a basketball player and you have an injury and you snap one of those ice packs and shake it up and all of a sudden it gets super cold because it's absorbing heat, that's a chemical reaction going on inside that ice pack. If you have one of those hand warmers that you pop those and put them in your gloves and heat gets produced, there's a chemical reaction going on in those hand warmers. Color change is another one. So if I had this paper and I burned it up, you'd smell it and it would no longer be white. That would be an example that a chemical change has happened and a new thing has formed. Paper became ash. Then the 4th choice was the appearance of an insoluble substance. Insoluble means it can't dissolve in water. So sometimes you mix together 2 fluidy kind of things and a solid can form. I don't think you would have any real experience with that. That's more of probably an official chemist world kind of thing to happen to somebody out there in the world of professional chemistry. see, number 4 is going to go backward. What is a chemical equation? So that's a shorthand method of expressing a chemical reaction with symbols and formulas. Rules, you have to know how the substances react and what new substances they form, and then the equation has to be balanced. So we're doing both of the answers instead of just one of the answers from number 5. That becomes a 2-point question. Side question that didn't make the quiz, I asked what kind of equations we're going to be writing in this chapter. You could say that they're called complete equations or molecular equations. There's also a thing called ionic chemical equations, and that is not appearing in this chapter. I don't think we do those this year at all, if I'm remembering correctly the rest of the year. But what kind of equations we'll be writing is complete or molecular equations. I'd rather have both of those words, like half a point apiece, complete and molecular, when we do that question tomorrow. Law of conservation of mass stays the same for number 6. Mass is not created or destroyed. And then follow up, who's the originator of that law? That would be Lavoisier. So Lavoisier is back in here, putting in an appearance. This is like in the 1700s. You don't have to write any equations today, but just to try to give meaning to what we're doing, we're trying to say things like, if we have some hydrogen and we put it together with some oxygen, like what would we get putting together hydrogen and oxygen? And there's actually more than one possible right answer for this, but you're thinking water. So that would be an incorrect chemical equation. Not say unfinished chemical equation, because we knew what was going together. We knew it was going to form. Hydrogen and oxygen will form water, but this isn't balanced. It's also not right because hydrogen never exists just as an H. Hydrogen is one of our elements that has, it's diatomic. Hydrogen comes in pairs. Oxygen also comes in pairs, so that's getting better, okay? But diatomic making water. The problem with this is it's unbalanced. This has 2 hydrogens and this has 2 hydrogens, so that's nice. But this has 2 oxygens and this only has 1 oxygen, so we would need to fiddle around with this. We would need a coefficient of 2 out there, so now I have 2 oxygens to match my 2 oxygens, but I just messed up the hydrogens. Now I have 4 hydrogens and this only has 2. So I need a 2 there, and now I'm good. I've got 4 hydrogens here, 4 hydrogens there, 2 oxygens here, 2 oxygens there. That's a balanced equation. You don't have to balance anything. That's just like a preview of where we're going and to understand what this is talking about. We have some things reacting together. We're producing something new. You know, that's a chemical equation. I'll just read verbatim the answer from my paper. It's just we're expressing in symbols and formulas what's going on with a chemical reaction here. That's where we are. Tomorrow 9-2. Grand total tomorrow is 22 points. Today's 6 popped into 10, and then we were adding in 12 new ones.